Find the standard equation for the hyperbola 9y squared minus x squared is 81. Might also be a good idea to take out that conics flow chart that I made. There's also a copy of it on, I think, one of the last pages of this section, this chapter, no, this section. And you can also track how we know it's a hyperbola from here. Both x and y are squared, and they have different coefficients. However, they have different signs. That's how we know. That's our big clue. So this really is not in standard form. The last example, example 1, was given in standard form. We wrote our answer for the last example in standard form, and that's where there's a 1 over here. So if we've got 9y squared minus x squared is 81, and we divide everybody by 81, we've got y squared over 9 minus x squared over 81 is 1, right? And again, this format is very, very telling. So what this gives us is, because this is the positive value, I'm going to write posi for positive, right? That makes this a vertical hyperbola. Okay, we do know we're still centered at the origin, just like the last couple examples. On the next page, you'll find examples that are not, or we'll introduce ideas where they're not centered at the origin, but for now they always are. The other thing we're interested in is this is 3 squared, and this is 9 squared. So again, you can see it really does not matter which of these is larger, it's about which one is positive. Okay, so I'm going to sketch out some axes, and let's start our graph, and we can start figuring out what this hyperbola looks like. Okay, I don't think I went far enough in this direction. Okay, we've got x, y. All right, so what do we know? Well, as I mentioned before, we definitely know our center is at the origin. We mostly don't know differently yet, so we may as well just stick with that for now. Okay. We also know we're going up and down 3 spaces, so 1, 2, 3. Point there, 1, 2, 3. Okay, and because this is on our positive or our positive variable, right, that makes these two our vertices. Okay, we're also going to go to the left and to the right because it lines up with x, 9 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a covertex. 1, 2, 3, 4, 5, 6, 7, 8, 9. Another covertex. Okay, so I'm going to sketch in that rectangle. It's a pretty wide rectangle, but that's fine. It doesn't really change anything we do. Okay. Okay. Okay, and I will trim this back just like before. Hard to get it right, or very precise, I guess. Okay, so we've got this set up. I'm going to sketch in my asymptotes, and you'll see there'll be really wide asymptotes this time. That's totally fine. It'll also mean our hyperbola is very wide as well. And then I'm going to come back to find the foci. Okay, so here we are. Okay, there's one of them. And the other side over here. Okay. Okay, So what are some of the pieces of this that we need to put together? Well, we need to find the location of the foci. We at least know they'll be here because they'll line up with the vertices, right? And then we need to find the equations of these two right here. Before I forget, I'm going to write out the value of the vertices. So the vertices are located at 0, 3, and 0, -3. I've been putting negatives first, so 0, -3. Like I said before, we need to find the foci. So let's actually figure that out. So that's going to be c squared is, and remember it's always the opposite sign, so a squared plus b squared. And so we're looking at c squared is 9 plus 81, which is going to be 90. C squared is 90. When we take the square root of both sides, we're going to get c, and this is going to factor, right, to a 9 and to a 10. Remembering 9 is a perfect square, so c is 3 square root 10, which is approximately, let's just put root 90 in there, 9.49. I might have run over myself a little bit here. 4, 5, 6, 7, 8, 9, 10. So I'll put it halfway in between. It's a little hard to see. Sorry about that. 4, 5, 6, 7, 8, 9. There's 10 and 9. And we are going to be halfway in between. So here is a focus. All the way down there, I'll put an arrow, is our other. I wrote on top of myself a little bit, sorry for that. Okay, so we can write out those ordered pairs. So the foci are located at 0, -3 root 10, and 0, +3 root 10. Okay, so let's go ahead and sketch in our hyperbola. Again, this one is really wide, and it just has to do with, these values that we were given. This is a big part of why I like the asymptotes so much. It gives us those kind of guidelines on how to draw it. Probably could have been a little closer, but the only other thing we actually have not quite done yet is find the equations of our two asymptotes. So I'm going to do that. I'm going to start over here with to do that. So remember, we're working off the equation y minus y1 is mx minus x1. That's the standard equation of a line. So first up, y minus, I'm just going to use the center again. So 0, I'm going to leave a space for my slope, and x minus 0. So I'm going to do this asymptote first. So starting from my center, we go up 3 and over 9. So 3 is my rise, 9 is my run. Notice that that can be reduced. We should reduce it. So we end up with y is 1/3 x. And I guess I should write them over here. Okay, to do the same for the other one, we're going to say y minus 0 again, leave a space, x minus 0 again, and now we're going to measure from center. We're measuring this one. So this time it's down 3 over 9. So this gives us -3/9, or when you reduce, -1/3 x. And I'll add that over here. Okay, that's all the required information. Again, you can always add the covertices if you want. Not absolutely required, but in our case that would be -90 and 90. So you can always add those to the list. All right, See you in a couple of pages while you work on hyperbolas not centered at the origin. And the good news is you can carry a lot of this information over. You don't have to start from scratch. A lot of our process of finding these points will still be there. It'll just be a matter of starting in a different location for your center. All right, see you in a bit.